Here we have part 2 of topic 26, discovering properties of exponents. So we're going to move along to activity 3, quotients of powers. Now what happens when you divide powers with the same base? So quotients are dealing with division. Quotient is called the answer after you divide something. So we're going to look for a pattern as you fill in the table below. So our first example is done for us. They have 2 to the 6th over 2 to the 4th. Now here, when we're expanding something, this 2 to the 6th means that we're multiplying 2 6 times. And when we're multiplying 4, we're multiplying it, 2 to the 4th, we're multiplying it 4 times. So, because we know that we can reduce when we are dividing a number by itself, it reduces to 1. That's exactly what is happening here. So once they reduce, if they see the same number in the numerator as they do in the denominator, it simplifies to 1, and all we're left is 2 times 2, or 2 squared. So if we move to the next example, we have 5 to the 7th over 5 squared. So that's the same thing as 5 times, as 5 times 5 times 5 times 5 times 5 times 5. Is that 7? 1, 2, 3, 4. Yes. Still gotta count. And over 5 squared. So that's the same thing as 5 times 5. So what we're going to do now is anytime we see the same number in the numerator as the denominator, that's going to reduce to 1 if we were to divide those two. So 5 divided by 5 gives us 1. 5 divided by 5 gives us 1. And we're just left with this value right here. So we're going to be left with 5 to the 5th power, because we see 5 of those 5s. Now we can do the same thing with negative numbers. Again, I like to write my negative numbers in parentheses, so that way it is easier to identify that we're talking about this entire quantity, in this case of negative 7. So if we were to expand this, we get negative 7 times 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 negative 7 over negative 7 times negative 7 times negative 7. Again, we're going to go through and reduce. So we have negative 7 divided by negative 7, negative 7 divided by negative 7, negative 7 divided by negative 7. And we're left with all of these. So this reduces to negative 7 raised to the 6th power. Now again, we can do the same thing with variables. So we'll expand a to the 8th. We get a times 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 a, and divide that by a times a times a times a, and we'll reduce them. Once we see the same number in the numerator and the denominator, they reduce to 1, so we can cancel them out. And we're left with this value here, which is the same thing as a to the 4th. So a rule that we see here is when they have the same base, so when there is the same base, and you are dividing, we subtract the exponents. So generally, if we have x to the m divided by x to the n, assuming that m and n are random numbers. This is the same thing as x to the m minus n. And we always go from the numerator to the denominator. Now, if we want to simplify the rule here, we have 5 to the 12th, y to the 20th, over 5 to the 7th, y to the 8th. So we are only going to be dealing with values that have the same base. So we have 5 to the 12th and 5 to the 7th. That's going to give us 5 to the 12 minus 7. And when we are dealing with y to the 20th and y to the 8th, we're going to have y to the 20 minus 8. And this is going to simplify to 5 to the 5th times y to the 12th. Moving on to activity 4, we have powers of powers. So here we might have a power raised to a power. So if we're looking for the pattern that we see here, in this example, we have 2 squared raised to the 3rd power. So that means that this entire quantity of 2 squared, we're going to see that 3 different times. 1, 2, 3. So if we multiply this out, we're expanding that 2 squared. Well, that's the same thing as 2 times 2. So we're going to write that quantity 3 different times. 2 times 2, times 2 times 2, times 2 times 2. 1, 2, 3. Now, how many 2's do we count here? We count 6. So 1, 2, 3, 4, 5, 6. Same thing as 2 to the 6th. Now, here, if we have 3 squared raised to the 4th power, that's the same thing as 3 squared times 3 squared times 3 squared times 3 squared. And if we were to expand that out, well, 3 squared is the same thing as 3 times 3, 3 times 3, 3 times 3, and 3 times 3. So how many 3's do we count here? Well, we count 8. So this is going to be 3 to the 8th power. Now we can also do it with fractions. Fractions are our friends. They are numbers too. So this is 1/3 to the 3rd power raised to the 4th power. Notice here how we're using both parentheses and brackets. That's to differentiate between the two. Now this 1/3, we're going to see it 3 times, and then that whole grouping of 3, 4 times. So we're going to break this apart to 1/3 times 1/3 times 1/3. So that's our first grouping of 3. And now we're going to repeat this 4 separate times. Really killing me here with all the numbers. 1/3 times 1/3 times 1/3. That's our second grouping. 1/3 times 1/3 times 1/3. That's our fourth grouping. And 1/3 times 1/3 times 1/3. That's our fourth grouping. So here, how many 1/3s do we count? We count 12. 1/3 raised to the 12th power. We can also do it in combination. So if we see 7 to the 5th times y to the 3rd, and that whole grouping we see twice, well, if we expand that, that's the same thing as 7 times 7 times 7 times 7 times 7 times y times y times y. That's our first grouping. And 7 times 7 times 7 times 7 times 7 times y times y times y. So how many 7's are we multiplying here? Well, we have all of these 7's, that's 5 there, and 5 here. So we're going to end up with 7 to the 10th. And how many y's do we count? Well, there's 3 here that we're multiplying, and 3 here. So we're dealing with y to the 6th. So if we were to describe this pattern, what we're doing here is when we have a power raised to a power, we are multiplying the exponents. Because think about it here. What's 2 squared raised to the third? 2 times 3 is 6. That's our answer. 3 squared to the fourth. 2 times 4, that's 8. That's our answer. 3 times 4 here gives us 12. And now here we have 7 to the fifth and y to the third squared. So we're going to multiply our 5 times 2, which gives us our 10. And then if we deal with our 3 times 2, that gives us our 6. So if we were to generalize it with a rule, this is x to the m raised to the nth power. This is the same thing as x to the m times n. And if we want to simplify this, the example right below, 8 to the 20th raised to the 34th, that's the same thing as 8 to the 20 times 34, which is the same thing as 8 to the 680th power. Whew, gosh. And that is activity 3 and 4.